How the moon controls the ocean, bedtime science facts. You don't feel it, but the moon is pulling you. Not with ropes or chains, not with a sound or a whisper. But gently, slowly, and persistently, it tugs at everything around you. The oceans respond most dramatically, rising and falling in a rhythm older than any civilization. And tonight, while you lie quietly in bed, the moon is choreographing a planetary dance that began long before humans learned to count the days. Let's begin at the edge of the sea. Imagine standing at the shoreline. The tide is low. The wet sand glistens like a sleeping mirror. A crab scuttles by, unaware that it's being nudged by celestial physics. Far above, the moon hovers in the sky, glowing pale and ancient, as if watching over the water with a calm and knowing eye. But how does it happen? How can a floating sphere, 384,400 kilometers away, move entire oceans? To understand that, we must return to the language of gravity. A gentle gravitational hug. Gravity, that quiet force, is everywhere. It holds your feet to the floor. It keeps Earth wrapped around the sun, and the moon tethered to Earth. But gravity isn't just an anchor, it's also a stretcher. The moon's gravity doesn't just pull Earth, it stretches it, like soft dough under a warm hand. This stretching creates what we call tidal bulges, two of them, actually. One on the side facing the moon, and the other on the opposite side. These are the ocean's answer to the moon's pull, slow, bulging waves that wrap around the planet in a graceful, looping rhythm. It's as if the moon were saying, "Come with me," and the oceans, obedient but not hurried, follow. Every day, as the Earth spins, different parts of the globe move through these bulges, creating the tides we see, high tide when a bulge is beneath you, low tide when it's not. But this is no instant push and pull. The moon influence is tender, and the oceans respond slowly, with inertia. There's a delay. Like a lullaby echoing after it's sung. Earth's watery breath. The tides are often compared to the planet's breath. Twice a day, the oceans rise and fall, inhaling and exhaling as the moon drifts above. These tides don't just move water, they move life. Tiny plankton rise to the surface with the tides, feeding fish. Mangroves drink and rest in time with the waves. Even some species of coral wait for the exact height of a tide to release their eggs. In ancient times, early coastal cultures watched the moon carefully, not just for beauty, but for knowledge. Polynesian navigators, African coastal communities, Indian fishermen, all learned to read the sea's slow language. Long before science gave us formulas, the moon was already our guide. But it's not only the moon at work here. There's another, less famous partner in this watery duet, the sun. A three-body waltz. The sun is much farther away, but far more massive than the moon. Its gravitational pull also affects the tides, although less dramatically. When the sun, moon, and Earth align during new and full moons, their forces combine, creating extra high tides called spring tides. When they form a right angle, during quarter moons, their pulls partially cancel out, causing gentler neap tides. The ocean becomes a slow-moving canvas, painted by the angles of celestial bodies. It's a silent, continuous, elegant equation. The water swells, retreats, swells again, never tired, never hurried. If you could watch the Earth from space, you'd see this, blue bulges rolling across its surface, like invisible hands brushing across a giant sphere. You'd see the moon leading the oceans in an ancient rhythm, like a conductor with no baton, just presence. But here's a question that rarely gets asked: why do we have two high tides each day, one facing the moon and one away from it? Now we're touching the edges of deeper science. The mystery of the opposite bulge. One high tide makes sense, it faces the moon directly. The moon pulls the water toward it. But what about the other one? To understand this, we have to look at motion. The Earth and moon aren't static. They spin around a shared center of mass, a point called the barycenter. It's not in the middle of Earth, it's about 1,700 kilometers beneath its surface, on the side facing the moon. As Earth orbits this point, it creates a centrifugal effect, like the way you feel pushed outward when spinning on a merry-go-round. On the side of Earth opposite the moon, this outward push is slightly stronger than the moon's pull, so water bulges outward there too. So Earth ends up with two bulges, one pulled by the moon, the other pushed by motion. Together, they create the cycle of tides we live by. It's not just physics, it's poetry in orbit. The result? Every beach, every bay, every corner of the ocean feels this rhythm. The water levels rise and fall like a planetary heartbeat. And it never stops. Even when you sleep, the ocean moves quietly outside, listening to the moon. But the moon's influence doesn't end at the ocean's edge. It whispers to the land, to time itself. Could it be that the moon, through the tides, is slowly changing the Earth? That's where our story flows next. Now we discuss tides through time, how the moon slows Earth and shapes life. As you lie still beneath your blanket, the moon continues its quiet task above. It doesn't rest, doesn't hurry. It simply pulls. And pull by pull, night by night, it is changing the Earth, not just the tides, but time itself. Let's return, just for a moment, to Earth's very beginning. Over 4 billion years ago, the planet spun much faster than it does today. One day lasted only about 6 hours. Sunsets came quickly. Nights were short, and winds were fierce. And floating much closer in the sky, the moon looked enormous, almost 3 times bigger than it appears to you now. It wasn't peaceful then. The early Earth was wild and volcanic, and the moon had only just been born, most likely from a collision with Mars-sized body that scraped Earth into space, which then gathered and cooled into the moon. A chaotic beginning. But from that chaos came balance. As the moon settled into orbit, it began its long, steady influence. And in that quiet pull, on the oceans, on the crust, on time itself, it became one of Earth's greatest sculptors. The drag of time. Each time the moon tugs on Earth's oceans, something subtle happens: friction. Tidal friction, to be precise. The moon pulls the ocean. The ocean rubs against the Earth's crust. This rubbing acts like a brake, ever so gently slowing Earth's rotation. It's as if the moon is holding Earth's hand, and as Earth tries to spin, the moon gently says, "Not so fast." Because of this slowdown, Earth's days are getting longer, by about 1.7 milliseconds per century. That may not sound like much, but over millions of years, it adds up. Fossil evidence tells us that around 400 million years ago, in the Devonian period, there were about 400 days in a year. Earth still orbited the Sun once per year, but the days were shorter, about 22 hours long. Now, there are 365 days in a year, and our days are roughly 24 hours. The moon is slowly stretching time, like a mother gently pulling the covers over a child, lengthening the quiet of night. So, if you've ever wished for longer days, thank the moon. But that's not all the tides have done. They've shaped not just time, but life itself. Life between the tides. Imagine, for a moment, that you are a creature crawling up from the ocean for the very first time. The tide has gone out. Pools of water remain in rocky crevices. Small fish flap helplessly. The air is humid, and gravity feels strange. But it is also a world of possibilities. Some scientists believe that tidal zones, the areas where the ocean meets the land, and the tides regularly rise and fall, may have been the cradle of complex life. These tidal environments are always changing: wet, dry, hot, cool. Organisms here had to be adaptable, creative, persistent. Some scientists think this back-and-forth rhythm encouraged early life to move, to evolve, and to climb. Tides may have been nature's first challenge, and in meeting that challenge, life took bold steps forward. Even now, some of the most extraordinary life on Earth lives in these zones: sea stars clinging to rocks, fiddler crabs dancing through mud, tiny snails riding foam like ships. They move with the tide. Their clocks are set to the moon. And so is yours, in a way. Your inner ocean. Inside you, tides still move. Your body is mostly water. Your cells rely on salt balance, water flow, and even pressure to function. There are rhythms within you, your heartbeat, your breath, your sleep cycle. Some researchers have even studied the idea that human biology subtly syncs with lunar and tidal cycles. Though the science is still evolving, the poetry remains. Our ancestors certainly believed it. Farmers planted with the moon. Fishers followed its phases. Ancient Chinese medicine, Hindu astronomy, and indigenous knowledge across the world all spoke of a moon-touched body. They saw connections we now seek to understand. Even today, certain species time their behavior by the moon. Coral reefs, for example, spawn in massive, luminous displays during full moons, releasing millions of tiny eggs into the tide all at once, life timed to a distant glow. The moon is not just a rock in the sky. It is a clock. A metronome. A soft guardian of balance. And yet, its story is still unfolding. Because the moon is drifting away. Yes, it's true. Each year, the moon slips a little farther from Earth, about 3.8 centimeters. Not enough for you to notice, but enough to matter over time. It's like two dancers slowly spinning apart, still holding hands but stretching their arms just a bit farther. One day, far in the future, the moon will be so distant that Earth's tides will grow weaker. Eclipses will no longer occur in the same way. Earth's rotation will continue to slow. The days will stretch long. And the night will last deeper and wider than ever before. But for now, the moon is still close enough to matter deeply. Its rhythm is ours. So when you next see the tide roll in, remember, you are watching Earth respond to a partner in the sky. And as gentle as that movement seems, it has shaped continents, species, and even your sense of time. But here's a quiet thought to drift off with tonight. If the moon can shape the sea, and slow the spin of a planet, what else might it be gently guiding, without us even noticing? Now we discuss when the moon disappears, the future of Earth's tides. The moon is drifting away from us. It doesn't rush. It doesn't fall. It simply slips, a few centimeters every year, into the vastness of space. Like a ship setting sail with no wind, no waves, only time. And though it will take billions of years, its quiet departure has already begun. Tonight, while you sleep, the moon is farther than it was last night. And one day, though no one alive now will see it, Earth's tides will feel that distance. But what does that future look like? What happens when the moon no longer watches over our ocean tides? When the Earth's rhythms, once so tied to the lunar glow, begin to shift. Let's imagine it, slowly, softly. A fainter pull. As the moon recedes, its gravitational pull on Earth weakens. The tides, those graceful bulges of water drawn to the moon's side, will grow smaller. Their rise and fall will soften. Eventually, the high tides will shrink. Low tides will barely dip. The oceans, instead of breathing deeply twice a day, will begin to doze. And the days? They will lengthen. Without the moon's firm tug to keep Earth spinning briskly, our rotation will continue to slow. A single day may one day last over 1,000 hours. Imagine a sunrise that takes days to arrive, and a night that lingers like a cosmic winter. Plants, animals, even weather would all need to adapt. Some may not survive. Others might find new rhythms. But while moon leaves its physical touch behind, its influence, its legacy, will remain. Fossils in stone, fossils in memory. You can already see the moon's handiwork frozen in stone. Layered rock formations tell of ancient tides. Tiny shells embedded in cliffs whisper of waters that once rushed and receded, all because the moon called to them. In certain caves, you can trace the moon's influence in the chemical rings of stalagmites, growing in harmony with cycles as long as a human life. And we too will remember. Not just in data or science books, but in stories. Stories of the moon pulling oceans like strings on a harp. Stories of corals spawning under its light, of turtles crawling from the sea guided by its silver eye, of Earth itself slowing in its arms. In every lullaby, every tide chart, every time a child points to the moon and wonders there, the memory of the moon's pull lives on. But here's something even more remarkable. The moon may have shaped us in ways we barely understand. A moon-made civilization. Without tides, there might never have been coastal civilizations. No fishing villages timed to the sea. No trade networks built on tidal harbors. No mythologies inspired by the moon's phases, no Artemis, no Chandra, no lunar calendars to guide the planting of crops. Even time itself, as we measure it, may have come from watching the moon change. Some scientists speculate that human curiosity, the desire to explore, to measure, to understand, was born from watching the moon rise and fall, grow full and then vanish. It was predictable, yet mysterious. Ancient, yet always new. It gave us a pattern, a pulse. In this way, the moon didn't just pull on the sea. It pulled on our minds. It called us to wonder. And what of the future? As the moon fades from Earth's embrace, we may send our own kind to visit it again and again. Perhaps even live there. Maybe one day, our descendants will look down at Earth from the moon's surface and watch the gentle shimmer of blue tides far below. They may build observatories where lunar dust blows softly across solar panels. They may plant gardens under domes, watered in rhythms far removed from the ocean. They may sleep to the memory of tides they've never seen, and yet feel somehow familiar. Because the moon is more than a rock. It is a rhythm keeper. A teacher. A long-distance friend. The final reflection. So now, dear listener, as you drift into sleep, let your mind float back over all the waters the moon has touched. The ancient seas of early Earth. The tidal pools that sparked new forms of life. The heartbeat of coral reefs. The pulse in your own wrist. All of it, shaped by a celestial companion quietly pulling at us across the sky. And when you next see the tide roll in, or catch the soft glow of the moon through your window, pause. Listen. Imagine. That slow, invisible pull, it's still with you. Even as the moon moves away. Perhaps the most magical force in the universe, is one that pulls us gently, and never lets go.